Alright, this is the second video for the learning target number 3 with patterns and nonlinear functions. In problem 2, we're going to look at an illustration, and this is a really good example to look at because it does have the images drawn for us of a pattern of blocks. And in our table, we've been given how many blocks are on the edge of our image, and that indicates, or there's a way to indicate just because of that, how many blocks total we're going to have in our picture. So one block on the edge, there's only one block, so that one's pretty simple. One block is one block. But 2 blocks on the edge, well, I see an edge here and there's 2 blocks there, so if there are 2 blocks on the edge, that indicates that there are going to be 8 blocks total, and I could count these and there are 8 there. The next one, 3 blocks along the edge, and that's going to give us 27 total blocks in the picture. And then we don't have 4 and 5 filled in as far as the total number of blocks, but I do have a picture here, so that's helpful. If there's 4 blocks along the edge or 5 blocks along the edge, how many blocks are going to be in our picture? Now, we need to try to figure this out. We could count those, and that wouldn't be a big deal, but if I wanted to know what if I had 100 blocks along the edge, I would not want to try to count all of those. So there's got to be a way to figure this out. And that's what we're going to find. We're going to represent this using words and write an equation, and then we're going to graph it. So let's start looking at what's going on here. Our third column over here is just the ordered pairs, and this is going to be helpful to us when we start graphing. So we'll come back to this here in just a little bit. But let's talk about number of blocks on the edge. Well, I get this question a lot, and when I look at it, I think, well, there are multiple edges here. Which edge are they talking about? Well, think about, this is a 3-dimensional picture, 3 dimensions. We have the width of our picture, which is 2 blocks. We also have the length, which is called the depth. Actually, maybe this is the width and this is the length. It doesn't really matter, but there are 2 blocks along this edge. And then we have the height, and there are 2 blocks along this edge, the height of this picture. So when I think length, width, and height, hopefully something that comes into your mind when you're looking at this picture is volume, because you've talked about volume before. The volume of a rectangular box would be length times width times height. And let's try to apply that here. I mean, I'm just trying things. So I know I've got 2 blocks and 2 blocks and 2 blocks. Those are my 3 dimensions, or my 3 pieces there. So if I had 2, 2, and 2, because that's what I've been given there, 2, 2, and 2, what could I do with those? Let's think about volume. Volume is multiplication. So 2 times 2 times 2. What would that give us? What is 2 times 2 times 2? Well, that gives us 8, which is actually what I have in my table. So let's try to apply it to this one and see if it works. I've got 3 blocks along this edge, 3 blocks along this edge, and 3 blocks for my height. It's 3 blocks high. So if I have 3 threes, and let's try multiplying them. 3 times 3 times 3, what does that give me? Well, that gives me 27. So I seem to have a pattern here, and 1's pretty easy. If I have 1 times 1 times 1, that's still 1. So it's working. So let's try to apply it for 4 and 5. So for 4, let's write out 4 fours. 3 fours. 4 and 4. Length, width, and height. And let's write out 3 fives. 5, 5, and 5. Well, what's 4 times 4 times 4? That's going to give us 64. So let's write that in up here. So that would be, our ordered pair would be 4, 64. And then 5 times 5 times 5 would give us 125. So if I write that in, that'll be 5, 125. Alright, so seems to be working out. So let's see what's going on here. I've got 3 2's and 3 3's and 3 4's and 3 5's. The number 3 keeps occurring. Let's write this rather than 2 times 2 times 2. What would this look like? How have you seen this written before? You have 3 2's. So thinking about, you've seen this before, I have 2 to the 3rd power. I have 3 3's. This would be 3 to the 3rd power. The same thing would apply here for my 4's and 5's. I have 4 to the 3rd and I have 5 to the 3rd. So I'm taking my 1, 2, 3, 4, 5 that I have here, and I'm raising it to the third power. Well, that's basically what we need to do first. We need to write this in words. So what would we write here? Let's write for our words. Let's write it out. We have the total number of blocks. So the total number of blocks, which let's go ahead and make sure we write in that that is our y value. So the total number of blocks is y. Well, what are we doing to y? Well, not what are we doing to y, but how are we getting y? Well, we're getting y because we're taking the number of blocks. So y is, we're taking the number of blocks and we're raising it to the third power. Well, what's another word for this, for raising 3 to the third power? Well, another word for that is to cube. The total number of blocks, y, is the cube of the number of blocks on the edge. So that's in words, exactly what we had. Now the blocks on the edge is represented by an X, so you want to go ahead and fill that in just so that you can refer back to that here in just a few minutes. But that's what we have there. We've got the total number of blocks, y. The way we get that is by cubing the number of blocks on the edge. So now what we need to do is we need to write this as an equation, and then we're going to have to graph it. So over here, I'm gonna write my equation over here. And if you've got the words written, the equation is very simple. You take the total number of blocks, and which is y. So y is. Now, when we've been writing equations, the word is should give you a clue that it's equals. Y is, or y equals the cube of x. Now I'm taking out all this stuff that tells me what x is. I just know that I've got to cube x. So that's going to be x cubed, or x to the third power. And there's my equation. So the last thing that we have to do is to graph this. Okay, so we need to set up an x and y axis, and we need to graph it. So I'm going to go over here and create an x and y axis. Now notice that your x's are increasing 1, 2, 3, 4, 5, so that's pretty easy. And for the sake of space, I'm not going to label everything, but you need to always make sure that you are labeling what your x and y axis represent. Try to make sure we have enough room here to see this. So make sure you always write what they represent. Now, 1, 2, 3, 4, 5. Now, our y values, 1, 8, 27, 64, 125, increasing very, very quickly. So I don't want to count by ones or twos or anything like that. So I think what I'm going to do is I'm going to count this off by increments of 25. So here's 25. This would be 50, 75, 100, 125, which is where we need to be, and 150. So this is going to be my 50. This is 75, so this is 100 here, 125, and this one's my 150 at the top. Alright, so let's start plotting these points. I've got 1, 1. Well, that's going to be way down here, very, very close to the bottom. I've got 2, 8. Again, that's still also going to be very, very close to the bottom. 327. Well, here's my 25, so this one I can actually move up a little bit more. So 327, maybe somewhere right there. 464, I've got 75 there, so I'm not quite to the 75, so we'll drop it down some. And 5, 125, and that one's easy because that one's clearly marked, so 5, 125. Now, you could try to make this into a line, but it clearly curves up, and it's increasing very, very quickly. Now we're not going to connect these dots because that would indicate that I could have 1.5 blocks, and I'm not going to have half a block. So these dots are just going to increase here very quickly in a non-linear function manner, and so there is your words, your equation, and your graph to this nonlinear representation. So take those three pieces and go ahead and try your turn problem 2. Now this one only has 3 pictures. It does not have the picture for 4 and 5. So what you're going to have to do yourself here is either draw those pictures or go ahead and analyze what's going on and figure out what 4 and 5 will be as far as the y values. But make sure that you write this using words, an equation, and a graph. Now, for the sake of time, I'm going to go ahead and make a third video for your turn problem 3, or for the example and the your turn problem 3. So once you finish this one, go on to video number 3 to finish up your notes and to do the summary questions.